So in today's lesson, we're going to discuss Chapter 1, Mass Numbers and Isotopes. So in the previous video, we already took a look at what protons, neutrons, and electrons are. So if you don't know what those are, go back to the last video, read your book, and also check out the posted lecture notes to help you understand what those are. But you would have already seen these slides, okay? So here's this slide, atoms. If the atom is electrically neutral overall, then the number of protons equals the number of electrons. Remember, protons are positively charged and electrons are negative charged. And so if in your nucleus you have 3 positives, and we're just going to omit the neutrons for this discussion. Let's say in your electron cloud, you have a minus, a minus, and a minus. That's 3. So 3 minuses and 3 positives gives you an overall neutral. 3 plus negative 3 equals 0 equals neutral. So you have a neutral atom whenever the number of protons equals the number of electrons. Okay. The mass number is the number of protons in the nucleus, which is also, I said mass number. The atomic number is the number of protons in a nucleus. So you might actually find a periodic table, and you'll see carbon as element 6, and you'll see something that looks like that. And so what we're talking about right here is this number right here. That's going to be called the atomic number. And because the atomic number of carbon is 6, I know that that 6 equals 6 protons. Okay, now let me just ask you, if I told you that carbon atom is neutral, can you go ahead and infer how many electrons there are? Yes. If neutral, it must have 6 electrons. And I'll denote electrons with an E with a minus sign, superscripted. Okay. And so what you're going to find is whenever you don't have a neutral atom, it's going to be called an ion. But that's not where we're going right now. We're going to go here to isotopes. So an isotope is an atom of the same element, but they have different number of neutrons. Different number of neutrons. You may have heard of carbon-12 and carbon-13, and maybe even carbon-14 as in the dating method. Okay, well, they're all carbon, and they appear to all be neutral. And so each one of these has 6 protons. But what happens is they differ in the number of neutrons, okay? I know that they have 6 protons because I looked at the periodic table and noticed that carbon has a 6 for the atomic number. And so if you take carbon-12, the way you can find the mass is the isotope is, if you look below on the slide, it says mass number is the number of protons and neutrons in the nucleus of an atom. And so what this number represents is protons plus neutrons. Well, we know that in order to be called carbon, it must have 6 protons. And so 12 minus 6 equals 6 neutrons left over. I know that because I told you it's carbon-12, so I'm going to take that as my original number. I'm going to subtract out these 6 protons, which leaves me with 6 neutrons. And I know that because the mass number is 12, and the mass number, according to this definition, is the number of protons plus neutrons. I knew how many protons it was from the atomic number, and so I had to solve for the number of neutrons. Now, how does that differ from carbon-13? Well, carbon-13 has a mass number of 13. We're still going to subtract out those 6 protons, and so now I'm left with 7 neutrons. And so carbon-13 has 7 neutrons. Carbon-12 has 6 neutrons, and of course carbon-14, if you were to do the same kind of math, you would find out that it has 8 neutrons. And so the question is, what is the relationship between these 3 species? They're the same atom, right? They're all carbon. They're all neutral, so they're not ions, and so that makes them isotopes, atoms of the same element that have a different number of neutrons. And I've already kind of talked about mass number. I jumped ahead. Hopefully I didn't confuse you too much by jumping ahead. The mass number is the sum of the number of protons and neutrons in the nucleus of an atom. Of course, protons and neutrons are always in the nucleus of an atom, right? And so given the mass of an atom, which is what I did, I told you it was 14, I told you it was 13, I told you it was 12. You can determine the number of neutrons by subtracting the number of protons from the mass number, which is what I just did previously, okay? Oftentimes the unit for the mass number is just U, or the unit, okay? For instance, hydrogen, hydrogen gas, H2, one of our diatomic molecules, it actually has isotopes that are witnessed. And so hydrogen simply is a proton without a neutron. And so the mass number equals 1. And so if you take 1 and you subtract out the proton, because its atomic number is 1, you get 0 neutrons. Okay, but if you take its isotope called deuterium, notice that it has a proton and a neutron, so it has a mass number of 2. Subtract out the proton, so now you have 1 neutron in deuterium, which oftentimes is called 2H, and that's called 1H. And then tritium, a rare form, but it does exist, of hydrogen. It has 2 neutrons, actually, so it has a mass number of 3 because 2 neutrons plus 1 proton gives you 3, the 1 proton, again, coming from the atomic number. So all these are isotopes. They all have 1 proton, designated by the red dot. That gives its identity as hydrogen, but the differing number of electrons is what makes this, or not electrons, sorry, neutrons is what makes these isotopes. So briefly, I want to quickly look at this. So if you get out your periodic table, how many electrons does a neutral, carbon atom have? Well, the answer should be 6, because that is going to balance out with the number of protons, which is 6 according to the atomic number. That should also be 6. How many neutrons does carbon-13 have? Well, we've already solved this, but 13 is the mass number indicated by that superscripted 13 by the atomic symbol of C. 13 minus 6 gives you 7 neutrons. If C has a mass number of 12, how many neutrons does it have? Well, mass number of 12 minus 6 equals 6 neutrons. And then how many total subatomic particles are in the nucleus? So that's just another way of saying protons plus neutrons. And so that's a pretty easy one. It's right there. That's the mass number. So total subatomic particles in the nucleus is another way of saying mass number. And so the mass number is indicated right there, number of protons plus neutrons. If C has a mass of 14, how many neutrons does it have? So 14 minus 6 gives you 8 neutrons. C had a mass of 12 and another 13. What's the relationship? So they're both carbon. They're both neutral. They have differing number of neutrons. So that makes them isotopes. And if 2 atoms differ in atomic number, are they the same element, different element, or isotopes? Well, if you have a different atomic number, according to the periodic table, you're a different atom altogether, or different element. For instance, carbon is 6. If you add a proton, that changes the atomic number to 7. So if you look at your periodic table, you now just became nitrogen. Okay, and so this is the simplest way to write these out. It's called the isotope notation. And so what you'll see is the atomic symbol. And you'll see this a lot in Chapter 10, Nuclear Chemistry, as we balance nuclear equations. But up in the upper left corner, superscripted, that's going to be the mass number, which is the total of protons and neutrons located in the nucleus. And the bottom number, subscripted, is the atomic number. So if you were to find iron on the periodic table, it would look something like that. You'd have a number, the mass number down there. But in isotope notation, you're going to see it written like this. So just be familiar how to read that. And so you may want to get your calculator out to solve these last problems. So AU is going to be gold, and so right here we have mass number. So how many protons and neutrons are located or are in each atom. And so the number of protons is easy. It's just going to be the same as the atomic number, which is 79 right there. And then neutrons is just going to be the mass number, which is 197 according to this notation, minus number of protons. And according to my calculator, you should get 118. Okay. And then, of course, we have sodium right here. Protons is 11. Neutrons is going to be mass number minus number of protons, which is the same as the atomic number. And so do that subtraction, you should get 12 neutrons. That'll take you home. Okay. Try completing this table on your own. Okay, this is a neat table. I always like it because it gives a lot of information. And so see if you can fill this out. And if you have any trouble with it, just go ahead and send your instructor an email for some help. Okay, but just notice the columns, number of protons. So what you're going to do is find the atom that represents the atomic number of 80. And then it tells you the number of neutrons. So what happens if you add 80 and 120? You should get 200, correct? So the isotope symbol should be 200 over 80. So all you have to do is get your periodic table out and figure out what the atomic symbol is that goes with that, okay? All right, y'all have a great day.